Here I have problem 6 from the 2023 AMC 12A. Now AMC stands for the American Mathematics Competition, and this is the qualifying exam for the AIME, the American Invitational Mathematics Exam. Okay? And so this is going to be an early problem of the 25 problems, which means it's a bit on the easier side, but this can trip you up in certain places. So again, the question says, points A and B lie on the graph of y equals log base 2 of x. The midpoint of AB is 6, 2, or the segment. What is a positive difference between the x coordinates of A and B? All right, so it has the graph, all right? So maybe it's a good idea to draw a picture to get us acquainted with what log base 2 of x looks like. And so, of course, we have 1, 2, 3, 4, 1, 2, just some sampling points. Now, the log base 2 of 1 will be 0. The log base 2 of 2 will be 1. So we have this point here. And the log base 2 of 4 will be 2 because 2 squared equals 4. And so we can interpolate these points. And so this is a general idea of what the graph of log base 2 of x looks like. So we have y equals log base 2 of x. And you can see that points A and B, all right, I'm going to have A in red and B in blue, they're going to lie somewhere here where the midpoint of the segment is 6, 2. So remember that for a midpoint, it's the averages of the coordinates. So which means that if we have let A to be equal to the coordinate x1, y1, and B equaling the coordinate x2, y2, then the midpoint is going to be the averages. So that means that here 6 is the sum of the x coordinates averaged. So that means that 6 is equal to x1 plus x2 divided by 2, like this. All right, and of course we have 2 is going to be y1 plus y2 over 2. So y1 plus y2 over 2. So we can solve these independently. We have 12 is equal to x1 plus x2. And here we have y1 plus y2 equals 4. But remember that because these are points on the graph of log base 2 of x, y1 is going to be equal to the log base 2 of x1. And y2 is going to be the log base 2 of x2. All right, like this. And that's going to be equal to 4. And now, remember that a very important property of logs, which says that the log base c of AB is equal to the log base c of A plus the log base c of B, which just means multiplication in the input corresponds to sums in the output. And so, of course, we're going to use the reverse of that to connect these together into a product. So we have here the log base 2 of x1, x2 is equal to 4. And that means 2 to the 4th power is equal to x1, x2, like this. And so that means that we have 16 is equal to x1, x2. And so that's going to be helpful here because if we have 12 equals x1 plus x2, then x2 is equal to 12 minus x1. And we can plug that back in here because, again, we want to solve for the values of these coordinates and then take their difference to find the answer because it's asking for the difference. All right, so 16 is equal to x1 times 12 minus x1. And we get 16 is equal to 12x1 minus x1 squared, which means we have x1 squared minus 12x1 plus 16 is equal to 0. And now you can use a quadratic formula. So then x1 is equal to, well, negative b is 12 plus or minus root of, well, b squared is 144 minus 4ac, which is going to be minus 6 times 4 is going to be, of course, 64. And we take that over 2a, which is going to be just 2. And so we have 12 plus or minus the square root of 80 over 2. Now, the square root of 80 is the same thing as saying the square root of 16 times 5, right? And 16 is a perfect square. So we have 4 root 5. And so we have 12 plus or minus 4 root 5 over 2, which ultimately, triangulating these three numbers, which just means factoring out the 2. I call it triangulation because you have this cool little triangle here. And what you get is 6 plus or minus 2 root 5 for x1, which means that x2, because x2 is equal to 12 minus x1, x2 is equal to 12 minus 6 plus or minus 2 root 5, okay? And that's going to be the same thing as saying 12 minus 6, and the minus of plus or minus is going to be minus plus 2 root 5. And so we ultimately get 6 minus plus 2 root 5. And the reason I write it like this is because it tells you that it doesn't really matter if you choose x1 to be 6 minus 2 root 5 or 6 plus 2 root 5. All we know is that x2 is going to be the conjugate of that. So if we choose x1 to be 6 plus 2 root 5, then x2 will be 6 minus 2 root 5. So let's do that. Let's say it's 6 plus 2 root 5 and 6 minus 2 root 5. And so taking the positive difference between these two is going to be the same thing as saying absolute value of x1 minus x2. Okay, just in case we picked the other way. We get the absolute value of 6 plus 2 root 5 minus 6 plus 2 root 5. And remember that you're just factoring out the negative 1 and distributing, so you have 6 minus minus 2 root 5, which is just plus. And here you can see that the 6's here cancel out. And we're left with 2 root 5 plus 2 root 5, which is equal to 4 root 5. And the absolute value of 4 root 5 is already positive, so it's the same thing as saying 4 square root of 5. And that's the answer. Now let's check if we have that answer in the multiple choice, because again, the AMC is a multiple choice exam. And you can see we do have 4 root 5. That is the answer. And that's how you solve this problem. Now, let me know if you had a different way of solving this problem. And there was one mistake that I made during the AMC when I was taking it, where I was not actually able to do this problem, even though I knew I was well able to do it long before. And I'm going to share this moment of vulnerability with you and tell you that when I said log base 2 of x1, x2 is equal to 4, I thought, oh, obviously, x1, x2 is equal to 2. And I said that because I forgot that logs answer the question of 2 to the power of 4 is equal to x1, x2. And instead, I did 2 to the power of x1, x2 is equal to 4. So that's a little stupid mistake I made there, and it just shows that even if you know how to do a problem, in the heat of competition math, you might be able to make a lot of mistakes. So make sure that you're level-headed, make sure that you're smart and careful about all of your processes and all your work, and try and avoid as many stupid mistakes like that as possible. Till next time.